As the new year dawns, Commonwealth Fusion Systems is inching ever closer to finishing SPARC, the world's first all-superconducting large tokamak. This will likely be the first machine in human history to create fusion power. This achievement should stand next to all the great human achievements of the last millennia. America has been exceedingly short-sighted when it comes to fusion energy. Federal support has never been significant. Congressional funding has barely budged in the last 20 years. This must change in the new year. America fought a decade-long trillion-dollar bloody war over oil, yet oil is nothing. Nothing when you compare it to the potential of fusion energy. We are looking at the most significant technology of the next 500 years. Fusion has taken billions in private investment from our wealthiest investors. The wealthy are not stupid, even if Congress is. Fusion means incredible wealth. It means economic prosperity for our country. It means military superiority. It means national security. While America wastes time, while Congress dithers, while our political leadership underfunds the pipeline of fusion talent, technologies, and ideas, China is building. They are building fast, right now. When it comes to fusion energy, America's time to wait is over. We need to act. We need to act right now. What follows is a national plan to achieve fusion power faster.
Number 1. We need to establish a national fusion database to share fusion data from old machines. We need this to validate artificial intelligence, modeling, and for reactor licensing.
Number 2. We need to model fusion reactors at extreme magnetic fields. We think we know what happens to tokamaks between 10 and 40 Tesla. But what about other machines?
Number 3. We need to solve the U.S. shortage for superconducting tape. We can support the domestic supply through funding for tape manufacturing and materials sourcing.
Number 4. Build a national fusion neutron source to test materials, validate components, and speed up fusion commercialization.
Number 5. We need to upgrade the magnet lab in Florida so companies can pay for time to test their own superconducting magnets.
Number 6. We need to create a test stand where components can be tested inside fully operating superconducting magnets.
Number 7. We need to fund research into fusion rockets. A fusion rocket would allow us to travel to Mars in a matter of weeks.
Number 8. We need a fusion rocket test facility. We could add on to an existing NASA site to set this up.
Number 9. We need to establish a national high-voltage test center where companies could pay for time to test their parts under extreme voltages.
Number 10. The U.S. needs to accredit a new degree in fusion engineering. This degree must be aligned with the needs of the fusion industry.
Number 11. We need to continue to fund alternative fusion concepts. This will keep the U.S. ecosystem fresh with new ideas. But any new ideas will need to meet a high bar to qualify for the money.
Number 12. We need to find ways to use artificial intelligence to help control and design these machines.
Number 13. We need to fund research into the deposition of sheets of superconductors. Right now, we only make this material as a wire, not as a sheet.
Number 14. We need to address the critical shortage of tritium in the United States. We need to stand up a plant similar to the one being built in Canada and support commercial training facilities.
Number 15. America needs to invest in advanced optics for excimer lasers. These are the only class of laser that is shot at high rates. But America has not funded enough development around these optics.
Number 16. We need to fund research into blankets. Fusion reactors need this for tritium breeding.
Number 17. We need SBIR funding to support plasma optics. Plasma optics could be a way to create laser energies beyond what we are currently capable of generating.
Number 18. America needs a dedicated program to commercialize subsystems for fusion plants. Small businesses could be set up around each subsystem selling their own diagnostics, injector, or heating tool.
Number 19. We need to expand the American supply of targets for inertial fusion energy.
Number 20. We need to support research into multicolor compression. The general idea is that adding bandwidth to this light will improve laser fusion's performance.
Number 21. We need funding to improve the codes we use to simulate these plants. We need this for plant regulations and for reactor modeling. Many codes are academic in nature. They have not been converted into commercial tools by software professionals.
Number 22. We need to organize regular boot camps for manufacturing firms. This will allow us to train machinists, sales professionals, and engineers in how to make stuff for fusion startups.
Number 23. We need to accelerate research on advanced steels and tungsten for fusion reactors. China has advanced beyond America in this arena.
Number 24. We need funding to generalize fusion diagnostics. Many of the best tools evolved in silos. For example, the best cameras are used for laser fusion but not used in magnetic systems. Small business funding would allow us to generalize these tools for many reactor types.
Number 25. We need to fund the limited reprocessing of spent nuclear fuel using fusion neutrons. The Department of War could allow this inside their secure facilities.
Number 26. We need to support standing up digital twins of fusion power plants. We need this for plant design, licensing, and safety.
Number 27. We need to expanded cost modeling tools. We need to include additional reactor designs like laser fusion, mirrors, and pinches.
Number 28. We need to increase the staff at the Nuclear Regulatory Commission to support licensing for fusion power plants.
Number 29. The government should consider expanding their loan program to cover fusion plants. These loans can actually generate government revenue when they are paid back.
Number 30. We need to increase the pipeline for laser diodes for fusion plants and other applications.